In this lecture, we're going to look at a couple of methods to determine whether our data that we're working with is coming from a normal distribution. So the idea is that we have some data, and that data is coming from, we do have it. We want to know whether it is normally distributed so that we can do something like maybe find the confidence interval for a small sample or something like that. There are two ways that we can check. The first of these we're going to look at is the histogram method, and the second of these a normal probability plot, or more generally a quantile plot. A histogram method is exactly how we've described it. You draw a histogram and you determine whether or not that histogram is bell-shaped. Now, for our purposes here, this histogram is bell-shaped. It's high here in the middle. It's low on this end, has a small, thin little lip, and the lip here is so small as it's non-existent. So this isn't perfect. You have to sort of use your imagination sometimes and have to have some experience in order to use this method to justify that your data is bell-shaped. When you look at the data, does it look like a bell? This is too subjective for some people's taste, so we have something that's a little bit less subjective. We'll call it a normal probability plot, and we'll be plotting lines or dots in order to show this. So let's have an example of what you need to do. In our first column, we're going to have our data. Now let me get my drawing implement out here. Here we have our data, and we have the smallest listed first, the second smallest, all the way listed up to the first. Then we have a column here, which every item here is the quantile of its corresponding element over here. So, and remember, the quantiles have to do with the position of the data within the set and not the data's value. The third column, we take the PPF function of this column here. Now, to test if something is normal, we'll have the normal distribution over here, but a quantile versus quantile plots can be done to check for any distribution. And then we'll plot these. This will be our X column. This will be our, well actually I got that switched around. This will be our X column, and this will be our X column, and this will be our Y column. And so we plot it. Now here, our first example, I am plotting a uniform data versus uniform theoretical. Okay, so my X is all theoretical PPF values. My vertical is all the values of my data. And this line here is just put in for the purpose of comparison. It is my line of slope 1. And notice here that my dots plotted the X versus Y are clustering around that line. A fat pencil would cover it all. And here I've got my normal plotted against a theoretical normal. Okay, and see again they cluster. Here on this last one, I have uh, a theoretical uniform plotted against a theoretical normal, and notice that you have it's sort of S-shaped around this line. Okay, uh, and you will have that sort of phenomenon when you do a uniform versus a normal.